Okay, let's get started. You flip. You'll find this, Leslie. Here we go. Shh. Here we go. Saul. Here we go. Okay. Come on, I hit play 8 seconds ago. Let's get started. All right. Hey, y'all. Yes, excellent. Everyone's listening. So we have a one proportion Z interval problem that we're going to run. We have this little tiny table of data from a survey of 6,230 unemployed adults, and they went ahead and checked a box for what they deem their marital status and gender. Okay? That's all we've done. All right, so it asks us to find a 90% confidence interval for the proportion of unemployed men who are married. All right, so the first thing I want to do is you should take out your calculator. I'm going to throw some words at you I haven't heard in a while. I want to do some marginal distributions here for this table. All right, basically I want to know how many checked that they were a man. So what's the total number of men? Use your calculator.
3,300.
Please stop saying 3,300. Sound like a 4-year-old. Great idea, Jarvis. Thank you. 3,000. So, if it's not helpful, just keep it inside your brain. Okay. 3,499. Now, Jarvis has decided to subtract that from 6,230 to find the number of people that checked woman. Excellent. You're so good. All right. All I did was I asked them to find the marginal distribution for gender. So they added these three to get that many men in the survey, and these three to get that many women. Because ultimately, Charlize, what I'm looking at here is it's more impactful to look at the proportion of married men out of all men, right? Looking at all people, I just care about, okay, if I look at only the men, what's the proportion that are going to be married? All right, that's what I care about for this problem. Okay, so the first thing I'm going to check, well, I guess the first thing I'm going to do is I'm going to make my first assumption. What's the first assumption I'm going to make?
Assumptions are checked.
No, it says make assumptions and check conditions. Now, Catherine does bring up a good point. If it already says that the assumptions and conditions have been met, you don't need to worry about this, but you know what's going to happen on the quiz. You're going to have to do it. Okay, so who wants to give it a try? Raise your hand. What statement would you want to write that assumes independence for this scenario? Okay, Leslie.
One man's marital status will not affect another.
Excellent. Another's, that's cool. I'm not like English, it's all good. One man's marital status does not affect other men and their status. Now, I feel fine about that.
Wait, doesn't that maybe I'm
Probably. But I was going to say, I'm cool with that as long as they're not married to another man, right? That's in the survey, right? If they're married to another man in the survey, well, then that's a problem. Okay? So as long as they're not married to another man in the survey, we're fine. Okay? Excellent. Thanks, Catherine, for that. I'm glad we got that on the recording. Okay, what conditions do we need to check with this assumption? Randomization. And 10%. Okay, so in my problem, I hope that I read something about a random sample of men. Let's see. It doesn't say random, so what statement are you going to write? Nice, good. These 3,000, I think it's 499? Yes. Men are a good representation of all, I believe it's unemployed men.
Unemployed married men?
Just men, because right now we're going to make a interval, Ureth, about the proportion of all unemployed men that are married. All right, so the survey does not only look at married men. It's not like we said, are you married? Okay, you're not a part of the survey. Okay, it was all the men. But the key thing was they had to be unemployed. So that's the key thing. Okay, now what about the 10% condition? Let's take 3,499 and multiply by 10, and what do you get?
34,900.
Basically 35,000, right? All right, so do we think that there are more than 35,000 unemployed men in America?
Yeah.
Absolutely, okay? It's sad, but it is true, okay? So that means that our sample size is not too large. So there are more than 35,000 unemployed men. So our sample size is not too large. Okay. I apologize for my handwriting being not great. It's hard to write on this thing. Okay, who has questions about, sorry, Edgar? This one? There are more than 35,000 unemployed men, so our sample size is not too large. I just apologize, okay? I'm so sorry. All right, what's really nice is that when you watch this, when I post it later, YouTube does closed captions. Right? So thanks, YouTube. Hashtag ad.
They don't always do it right, though.
Okay, well, Leslie, I mean, why do you have to rate my parade? I'm so excited. Okay.
Does your son do that? Does he do that?
Throw tantrums? Well, yes, he is 4. Yes, last night he got mad because he didn't get to watch TV. He lost his TV privilege, and oh man, he got mad. But he calmed down eventually. Huh?
Do you laugh?
No, we can't laugh at it. His brain cannot process it. Okay? That would be so mean to laugh. I just tell him, Henry, I understand what you want. We know what you want. You're not going to watch TV tonight. Tomorrow night, we'll watch TV. And then he gets really mad, and we just move on. Okay, and I've got 2 other kids, right, to keep me occupied. So it's not that big a deal. Hey, what's Catherine up to, right? It's not that big a deal. Okay.
I'm chilling.
With us. Okay. That's fine. Liam is always chilling, right? He's not even here yet. Let's go to the next assumption. What's the next assumption we're going to make? The sample size assumption. Now, I do my best every year to try to help your brain understand the process of these assumptions and conditions, right? So there's a reason that the last condition underneath the independence assumption is the 10% condition, because it's about the sample. So we just concluded the sample is not too big. So then the next statement should be, but it's big enough, right? So not too big, but it's still big enough. All right, so that's what I'm trying to help your brain understand the process of doing this. So the statement can be something like 3,499 is a large enough sample. And if you want to be more specific, you would say 3,499 unemployed men is a large enough sample. Okay, now with proportions, we have a condition we're going to check. All right, and so boys, this might be a little bit for, well, if you watch the video, you should be good here. The success failure condition. Excellent. Okay. So this is one where you're going to do n times p and n times q. Now I write that, but because we're given a table of values, I don't actually need to do any of these calculations, right? N times p is the number of successes, right? That's why it's right here, success failure. So that's successes. How many are successes in this scenario? We can't tell. It's in the table. Out of those 3,499 drivers, how many are married? Again, right? It's going to be weird, but sometimes we're going to do a problem where success is having cancer, right? It's not necessarily a success. Okay, so 1,356. Right. That's what I'm saying. So success doesn't always mean good thing. Now, to find failure, you can do it one of two ways. You can take the 1356 and subtract it from 3499, or you can add 472 and 1,671. Either way, you'll find your failures. 2143? Yes. All right. And what do you note about both those numbers? Not less than, not less than. They're both 10 or more, right? Much bigger than 10. So we definitely have a large enough sample. So both numbers are 10 or more. So our sample is large enough. Both numbers are 10 or more, so our sample is large enough. Yes, question? Yeah. Yeah, I mean, basically what I put up here, I expect to see on the test or the quiz. Now, boys, if you watched the video, you saw that this was a new thing we had to do at this point, okay? We're going to write a statement that says what we're about to do, okay? So here's the statement. And so I kind of like to do a little bit of like a breaking point here. I've just done a lot of work to make assumptions and check conditions. So I'm going to say the conditions have been satisfied. So I will use the normal model to run a one proportion Z interval. Okay, I'll say it again. The conditions have been satisfied, so I will use the normal model to run a one proportion Z interval. Now, this is the first one you've ever learned. Right? So right now in your toolbox, you've got one thing to do. All right? You've got a one proportion Z interval. That's all you've got. Right? Next week, I'm going to teach you a one proportion Z test. Then a week and a half after that, I'm going to teach you a two proportion Z interval and Z test. All right? So I'm just going to start to slowly build what you can do with these. Okay, so how's everyone feeling about this? And yes, you will have to do all of this on the quiz. Right, but again, prepare yourself, right? Thursday, you know it's coming. No tricks here, no tricks. Okay, so we haven't done anything yet, right? I know it feels like we have, but we haven't really. So I've run out of room. Sad. But if you haven't, you can keep going. If you have run out of room, maybe there's some space somewhere. Oh yeah, we haven't even done it yet. We gotta do the work. Catherine, where do I go, Catherine? Catherine, where do I go? Yes! The very back. The very, very back. If you've run out of room. If you haven't run out of room, keep going. Okay? Some people, if you want, you could you could do the work here, and then when I ask you in about 10 minutes to do this one, you could do that one on the back, if you'd rather do that. If you'd rather have it together. It's up to you. I don't care. Okay? It's just a warm-up. Yeah. Okay, I'm going to do it right here. So I'm going to cross it out, but you're not. Okay, so let's go ahead and write down the formula that I'm going to give you for these confidence intervals. So you're going to get this from me on Thursday. Okay, it's p hat plus or minus z star times the standard error of p hat. And I'm also going to give you another formula, the standard error of p hat, which is the square root of p hat times q hat over n. You will get these formulas on the test and the quiz.
The thingies?
Not the thingies? What's the thingies?
The star.
Oh, okay. Well, can I get to that tomorrow? Okay, they can watch the video on that. But this is all you're getting. And as some of the girls remembered from last week, is if you don't know how to use all of this, it's not going to be super helpful. All right, it is helpful, but I'm going to show the boys and any girls that were absent on Friday tomorrow how we can use this to do more stuff. Okay, but for today, all we need is this. Okay, so let's do some math. I'm going to change colors to show you that this is my mechanics in blue. Okay, so I'm going to write X is the number of successes. I know, Jarvis, it's weird to say this, but how many of our unemployed men are married? That's our success. So how many was it? Okay. Then I'm going to write the sample size. So how many unemployed men were a part of the sample? 3,499. So then P hat, right? P hat, our sample proportion, is going to be that fraction. 1356 over 3499. So you can take your yellow calculator and find what P hat is equal to. And I always go 3 numbers after the decimal. 388. Great. Okay. So I'm going to slot this right in to where it says P hat. Okay? So point.
Star and margin of error.
No, margin of error is actually Z star times the standard error, right? Because every interval we do, Jarvis, is going to be a statistic plus or minus the margin of error. So anything after the plus or minus is considered the margin of error. Basically, Jarvis, we're saying, I don't know what proportion of all unemployed men are married. My best guess, based on the survey, is about 39%, right? But I'm not confident in that necessarily because I haven't sampled many times or a large sample, right? Only, 3,500 men? It's not very many men, all right? So I'm not that confident in that number, so I give myself a little leeway above and below that to give myself an interval, somewhere in that interval. Okay, so Z star, we're doing 90% confidence. 90% confidence. So the girls should know this. Bianca, what Z star am I going to use for 90% confidence?
1.6.
Bianca! That was louder than I intended. I'm not actually mad. That was supposed to be funny. It sounded really bad. I'm sorry, Dor. Right? I'm so sorry. That was not my intention. Dor, are you okay? You're okay. Okay. It's not my intention. I wasn't actually that mad. All right, but now you guys think that I'm walking it back. I'm not mad. All right? I wanted Bianca to say it. I feel very embarrassed right now. 1.645. You were right. Yes. So let's bring it back. That's my bad. I messed up. Shh. Let's bring it back. For 90%, we're going to use 1.645. So this is one of those you need to memorize. Okay? You're going to memorize the Z star for 90%, and you're going to memorize the one for 95%, which you're going to try. Okay? Now, I will show everyone tomorrow, like I did on Friday for the girls that were here, how you can find these and why we're using them. Okay? But you need to memorize these two. Try these. 1.96. So I always think 95, 96. 1.96. Okay, times. This is where you're going to put P hat in the numerator. So 0.388 times. So it's always 1 minus this for Q hat. So that's going to be 0.612. Excellent. Over how many unemployed men were sampled? 3,099. Okay. Now, because on the quiz, I'm going to give you guys a Chromebook. All right, I sent you a link where you can go and find this. This is all the work you would need to show. Okay? So I'll go ahead and finish it for you. Remember, you don't have to show this step, but I just want to show you how you can find it. So in your calculator, go ahead and do the square root of, let's see, oh man, so much fun. I got it, man, don't worry about me. Don't worry about me, I'm good.
Mr. President, how do you get the 0.612?
I subtracted 0.388 from 1. So we're saying if we expect 39% of our unemployed men to say they're married, we expect about 61% to say they're not married. All right, so I got times 1.645. I got a margin of error. Here you go, Jarvis, what you're asking about. Of 0.014. All right, 0.01355, so 0.014. All right, all I did was I just did this in my calculator and got that. Again, I don't have to see this. It's nice because I can see the margin of error.
So you can just leave it as the whole thing?
Yeah, you can leave it like that, but then I need the answer, right, in the parentheses.
Oh,
Well, because I need the interval. I'm looking for the interval. This is just the algebra, like typing it out. All right, so you would take 0.388 and add 0.014. So 0.388 plus 0.014. 0.402. And then subtract 0.388 minus 0.014.
Does it matter what order you put?
It does, Jarvis. Lowest to highest, please.
Okay.
Okay? So at this point, we're almost done. We have one more thing to write, and then we're finished. Okay? We're going to write, I am 95%, I'm sorry, my bad, I'm so sorry. 90% confident that the true proportion of all unemployed men that are married is between 37.4% and 40.2%. And we did it. Yeah, that's a lot. That's going to go faster, right?
That's it?
That's it, right? That's one problem. That's called a one proportion Z interval. All right? So I want to say a couple more things before I let you guys move on to your own tries of this, right? Your own attempts. All right? The first thing I want to say is kind of going back to what Jarvis mentioned about the margin of error, right? But I want to focus on the interval, okay? The number one thing you should see about this interval is what's in the center of this interval. What's in the exact middle of this interval? Okay. Thank you, Bianca. You guys are awesome. 0.388. All right? That's the biggest thing I want your brain to know is that we built this interval around 0.388, right? Think about your favorite Jefferson Starship song, right? We built this city. Right? That we built. Thanks. We built this interval around 0.388. Okay? So you'll notice 0.388 is right in the middle. Right where that's a great way to think of it. Right where that comma is 0.388. Okay? But we don't know if that's really the true proportion for all unemployed men who are married. Right? But we think, right, with 90% confidence that it's somewhere in between these. Okay? So I want you to just remember that right in the middle is your statistic, your p-hat.